This tutorial is on molar conversions. Now remember, chemists use the mole concept to talk about the amount of substance in a chemical reaction. We don't use grams or anything like that. We measure stuff in grams, but we need to convert to moles to do the chemistry. Because we need to keep everything on an even keel, right? And 1 mole of a material contains the same number of particles as another mole of material, even though the materials may be different. So we've already talked about molar mass. In this tutorial, we're going to talk about how do we convert from moles to mass, mass to moles, and then the final thing is we're going to put it together and talk about how do we convert from the number of particles to moles to mass, or vice versa, mass to moles to particles. Okay, our first concept that we're going to understand and learn today is converting from mass, as which we weigh in the lab as far as materials, right? We weigh out 22 grams of sodium chloride or 52 grams of water, and we need to convert that to moles, right? Again, all chemistry is done with the mole concept, so we need to go into moles to be able to do a balanced equation and things like that. So the first thing we're going to do is write down the given amount in grams. This is what we're given. And then to go from mass, which is grams, to moles, we need to calculate or look up the molar mass of the compound. And if you don't know how to do that, you should review the previous tutorial on determining molar mass, or go back to your notes and look that up. Then we're going to use a conversion factor of 1 mole to the molar mass in grams, right? The molar mass in grams of that particular compound and 1 mole are the same thing. It's like 1 dozen equals 12. 1 mole, or 1 dozen, equals 12 things. So 1 mole of material equals this many grams. So when we do our conversions, we want to make sure that the moles part of the unit conversion is on the top, because we want to be able to make sure that's what we're desiring. That's what we want to find. So we've got to make sure that's on the top so that we do the ratio works out. And then we complete the appropriate math equation and do the calculation. So let's see how it works on the next page. Before we start doing any calculations, I want to let you know that today I'm going to show you how to do these conversions using the factor method. What I like about the factor method is that it keeps track of your units. And if you do the factor method correctly, your units will cancel in the proper order, and you will be left with the units you desire for your answer. If you don't do the factor method correctly, your units will not cancel, and therefore you know that you have an error in your setup, right? The factor method actually keeps track of all this, and therefore it's an easy thing to do, and you're not confused at the end or whether or not your units will match. So let's see how it works real quick. Okay, so the step 1 I told you to do was to write down the information you're given. So you're given 65 grams of sodium chloride, so we put that there. Now notice I put it always over 1. Some people don't, but I like to do that so I can make sure that this always stays in the numerator, right? Now here's the kicker here. This is going to be my conversion factor, the next step, because I'm going to convert it into something else. So I'm given this information here. I need to convert it into something else to get my next step. And in this particular case, we're going from grams to moles, right? So we want how many moles from this many grams. So we have grams, then we have to go from grams to moles. Now, how do I make sure that I've set this up right? First of all, I have to look up the molar mass of sodium chloride or calculate it. And that sodium chloride molar mass is going to be this unit right here, this number right here, the 58.5 grams. Now, how do I know that? Well, I can look it up or I can calculate it. You should be able to do both. You should be able to calculate it. And if you don't know what this means or what the molar mass of that concept is, you should go back and review your notes or look at other tutorials. Now, once you've got that, you've got to make sure you're on the right side of the ratio. So how do I know I have the right side of the ratio? Well, I know up here my units are grams. I can circle them right here. And right here I know that I need to have grams on the bottom, so I can cancel. And if I cancel them, grams will cancel, then I'm only left with moles on the top. And that's what we're looking for, how many moles. So when you do all the math and you do the division and multiplication, it's 65 times 1 divided by 1 times 58.5. And you should get 1.6 moles of sodium chloride. Now, one check is that the moles number is always going to be less than the grams number, always. So if you get a number here after doing the calculation of a number that's larger than what you started with, the mole number is larger than the gram number, you've done something wrong. All right. So the next one is how many moles are in 180 grams of water, right? So again, here's how we set it up. The first thing we do is we write down what we're given. We're given 180 grams. I put that over 1. Then we multiply it by our conversion factor. In this case, again, it's going to be moles over grams, right? Because, again, I want to cancel the number of grams, and I'm given grams on the top here. Therefore, grams has to be, if I'm given grams on the top here, grams has to be on the bottom in the next steps in order for it to cancel, all right? And, again, the molar mass of water is here, 18 grams. Now note, again, you should know this, but this is pretty obvious. The molar masses of these two things are different because they're different compounds. So this number will always change depending on what material you're looking at, right? The mole doesn't change because it's this number of grams per mole, this number of grams per mole, right? So the molar mass of water is 18 grams. I can calculate that or look that up. And then when I do my multiplication to division, the grams will cancel, and I have 180 times 1, 180 times 1 divided by 1 times 18, and my final answer is 10 moles, right? So you should be able to do that. Again, 10 is less than 180, so that's a mental check that I've done it right. Okay, so we've figured out how to go from mass to moles. And now we have to always be able to go backwards. So we need to go back from moles to mass. So again, it's the same basic process, except this time we're going to do things in a little reverse. In other words, the conversion factor is going to change. The process is the same, it's just that we have to change the conversion factor. So again, what we're going to do is write down the given amount in moles. We need to understand or calculate or look up the molar mass of the compound that we need. Now we're going to use the conversion factor of molar mass in grams divided by 1 mole or over 1 mole, right? We have to make sure that when we set up our conversion that our units on the top are in grams, and we complete the appropriate math calculation and then do the conversion. Again, this is very important. This time the grams are going to be on the top versus 1 mole. But previously, when we were going from mass to moles, we had moles on top and grams on the bottom. The unit that we want to find or determine is always the unit on the top. Okay, we've gone from grams to moles. Now we're going to do the reverse. We're going to go from moles back into grams. So again, here's where we are. We are looking for how many grams are in 2.2 moles of sodium chloride. So the first thing I do always using the factor method is I'm going to write my given information here, put that put a line underneath it and put my 1. So my numerator is 2.2 moles of sodium chloride. Again, I'm using the proper conversion factor here, which is the molar mass to mole conversion ratio. Again, so we need to make sure that our units cancel. So look at here, I have moles on the top here. I need to have moles on the bottom here for the cancellation. Therefore, by definition, I need to have grams on the top. Remember, the larger number is always going to be grams, and it's always going to be over 1 mole. And that's the molar mass of sodium chloride is this number here. So when we do all that and we do our math, make sure we get our cancels. Here's our units canceling. Moles, and I'm left with grams on the top. And so far, we need to do 2.2 times 58.5 divided by 1
times 1, which is 1, and the final answer is 129 grams. Now you can make sure that you've done it right by making sure that your units cancel and that you have the units that you want on the top after you're done. And the other self-check is the following. Look at the number of grams and compare it to the number of moles. The number of grams always will be larger than the number of moles. Right? The moles is going to be smaller always, but the grams is always going to be the larger number. So if you have a larger number here than the moles, then you probably did your calculation correctly. If for some reason you have a smaller number here than you do moles, you most likely, of what a lot of people do, have flipped this. So you'll have the 58 on the bottom instead of the 1 on the bottom and the 58 on top. And let's look at the second example here. How many grams are in 1.8 moles of water? Again, here's our given, 1.8 moles of water. Put that over 1. We multiply it by the conversion factor. Here's my molar mass of water. It's over 1 mole, 18 grams per mole of water. And again, molar mass conversion. And if you do the math correctly, it's 1.8 times 18 divided by 1 times 1. And therefore, you should get 32.4 in this case. Again, a self-check, is this number bigger than the moles you started with? It is. The other self-check is when we do the unit cancellation, you should be left with grams, which is what you're looking for. If you get it, again, if you get a number that's smaller here than it is here, you probably have flipped the conversion factor. You've put the 18 on the bottom instead of the 18 on the top. So it's pretty much that straightforward, right? There's nothing any more difficult than that. Okay, at this point in the tutorial, you're going to do 2 problems by yourself to reinforce what we just learned. The first one is going to be a mass to moles conversion, and the second one is going to be a moles to mass conversion. Now, to help you out, I've only chosen one material that you're going to go from mass to moles and moles to mass, and that is ammonia. And therefore, you're only going to have to calculate or look up 1 molar mass. And once you look up the molar mass for ammonia, which is NH3, you can use that number in both of these equations to streamline the process a little. So what you're going to do is you're going to quickly stop the video, write down the information that's on the screen here, do the calculations, then start the video again and I'll reveal the answers. So stop the video now. Okay, so here are the answers to the questions. Alright, so the first thing I'm going to talk about is, again, you needed to calculate the molar mass of ammonia. I've done it here. If you didn't get this answer when you're doing the calculation, or you looked it up and you didn't get the answer, you should go back and review how to calculate the molar mass. That's going to be important. So the first question was, how many moles are contained in 34 grams of ammonia? So the first thing we want to do is we want to write down what we're starting with. Here's my starting material, 34 grams of ammonia. So I'm going to write that down here, and then I got to make sure I put it over 1, which I've done that. Now, the next thing I need to do is make sure I use the right conversion factor. And since we have grams on the top here, we need to have grams on the bottom here. And then that leaves us with the mole on the top here. Remember, 1 mole of this is equal to 17 grams of this for ammonia. These two are equal. They're just different units. So then when we set up our equation, now we can see that the grams are going to cancel, the top and bottom. And then we're left with only moles on the top. And when we do the calculation, we have 34 times 1 divided by 1 times 17, and we get 2 moles. Self-check, is the number of moles less than the number of grams? It is, so that's probably a correct answer. Second question, what is the mass in grams of 3 moles of ammonia? Set up the same process. What are we given? We're given the number of moles. So we put that first here, and then we put that over 1. And now the next thing we do is we've got to make sure that our conversion factor is the right way. So we need to have moles on the top here, so we need moles on the bottom here. So 1 moles here means 1 mole here. And that leaves only by definition that the 17 grams is be on the top. When we do our cancellation, 1 mole to 1 mole, we're left with grams. And our final answer is 3 times 17 divided by 1 times 1. And we'll show we got 51 grams. Again, another self-check. Is the number of grams that we've obtained larger than the number of moles? It is. Therefore, we've probably done the calculation correct. If you get an answer where the moles is larger than the number of grams either you started with or ended up with, then you've probably have flipped the conversion sign, the conversion factor. So go back and check your math and your setup of your equation. Okay, so here's some more mass to moles practice. So as we've done before, what you do is you stop the video, write the information down in the table that you need, then you do the calculations, and then when you're ready you hit play back on the video, and I'll give you the answers. Now remember here, you have to calculate or look up the molar mass of all these materials to do the conversion. So it's up to you to do that. I'm not going to give you that here. That's just more practice for you, either looking it up or doing the calculation. So stop the video anytime you're ready. Okay, so the answers are in red. You had to calculate the molar mass for all those materials or look them up. So I've given you the answers here for the molar mass in grams. These are all these values here. And then you needed this value here to do your conversion. And then you should have gotten these values here. Again, look at this. The number of moles is always less than the number of grams. Number of moles is always less than the number of grams. So if this number is lower than this number as far as moles and grams, you've probably done the calculation correct. Moles has to be less than grams, always. If for some reason you struggled here and you got different answers, go back and see if you can figure out where you went wrong. If you're still struggling with it after some repeated attempts, you should come and find me and I could probably get you right back on track. Okay, so just like in the other practice table, this one now is from moles to mass. The previous one was mass to moles, and now we're going to go reverse, moles to mass. So again, you're going to stop the video, write all the information down that you need in this table here, look up the molar masses or calculate the molar masses for the materials that are listed here. You're going to put that number here in this column, and then you're going to do your conversion into grams. Alright, so stop the video when you're ready, copy the information down, and then when you want to reveal the answers, hit play again. Okay, just like before, these are the answers to the problems, alright? So I'm not going to dwell on the molar mass thing again. Here's the molar masses. You should either look them up or calculated them. They should be almost identical to what we have here, and they may be off by 1/10 of a gram or less, but they should be pretty close to these numbers. When you do the calculation correctly, you should get these answers here for your material. So boron would give you 13 grams, calcium chloride 244, etc., etc. Again, self-check. Is the grams number here in this column for the particular material greater than the number of moles that you started with? If it is not, then you have probably flipped the conversion factor setup, so you've had the wrong number on the top. If it is, if you get a larger number for grams than moles, you've probably have done the calculation correct. That's pretty much it for this particular thing. If you've got all these answers, then I would say that you have pretty comfortable with this conversion process. Okay, this is a pretty slide but it's just basically all the steps that we've done here, except for the last one, and we're going to talk about the last step in a minute. So this is a mass to mole to number of particle conversion. So, for example, I could ask you, if I have 22 grams of sodium chloride, how many particles is that? And you would say, well, we don't know how to do that, but there is a way to do that, and we're going to talk about it right now. So you've already done the first two steps here. So the first step here is we have grams, and then we've converted that. There's a conversion factors right here to moles. So we've already done that step already, right? This step has been done. You just had practice on it. We just did it, and here's an example of it down here. 10 grams of carbon. Here's my molar mass of carbon, and I get 0.8326 moles of carbon. The step that we haven't done yet, and we're going to show you in a few seconds here, is that once we are in moles, we can go back out and calculate how many particles that is. And this is where Avogadro's number comes into play, right? So now we have moles, we're going to go back and can calculate the number of particles. We can't go directly from mass to particles. We always have to go through moles, right? So this is our midpoint. We've always got to go through the center, right? We have to go here first, then we can go here, right? So once we get into moles, now we can calculate the number of particles. Because don't forget about the mole triangle. Once you're in moles, you can go to any part of the corners of the triangle. So we're going to show you how to do that here. Now, the second part is if we're in particles, we can go back into moles, and then we can get back into mass. So if I could ask you if we have 7 times 10 to the 26 particles of carbon, how many grams is that? Now, the first thing we need to do is calculate the number of moles from the number of particles, and then from the number of moles, we can go back into the mass. And we've already done this step too. This conversion here and this conversion here require Avogadro's number, right? So we're going to show you how to do that in the next slide. Okay, so here's our conversion sequence for going from mass to moles to particles. If I give you any one of these 3 items in a word problem, you should be able to come back and be able to tell me the number of moles or the number of mass or the number of particles, depending on which variable I've given you. So let's see how this works. All right. Anytime that you're going out of moles, if I give you moles and you want to find mass or particles, you're always going to be multiplying, right? So if I'm going out of moles, right, I'm going to multiply. So if I go out of moles this way, I need to multiply. So that's multiplication, and I multiply by the molar mass. And if I'm going out of moles this way to get the number of particles, I multiply by Avogadro's number. Anytime you come into moles, if so, for example, I give you the number of particles or I give you the number of grams, and you need to calculate moles, you need to go this way. If you're going into moles, you're going to always divide. And you're going to divide by the appropriate conversion factor. In the appropriate for conversion factor, when mass is involved, is going to be the molar mass of the material. If it's going to be number of particles, it's going to be Avogadro's number, 6.02 times 10 to the 23rd. So again, let's review this. Anytime you go into moles, you're going to divide. Anytime you come out of moles, you're going to multiply. Coming out, you're making bigger. Going into, you're making smaller. So that's how it works, right? So there's our conversions, right? So that's the simplest way we can put it together. So let's see how this works on a big scale now. Okay, so let's see how this works now that we've got all 3 things here. We have mass, moles, and particles. And we've only done the mass moles ones before, so now let's give you a couple examples of how we go from mass to particles and particles back to mass. So in our first problem here, we have how many particles are in 45 grams of sodium chloride, right? Now we always have to go through moles to get from the mass to the particles. We cannot do this. We cannot go directly from here. We always have to go through moles, and then vice versa. We cannot go through here. We always have to go through moles. So think of moles as your stopping point in any of these calculations. So I'm giving you 45 grams of sodium chloride. So there's our 45 grams. That's my start point, right? And our first thing to do is remember, when we go into moles, we always divide. Going into moles, we're going to divide. And in this case, from mass to moles, we use the molar mass to do that. And we divide 45 by 58.5, which is our molar mass of sodium chloride. And we get 0.77 moles of sodium chloride. Now the next part of the question is, okay, now that I have the moles, I want to find out how many particles. So remember, we're going out of moles, we multiply, get larger, and we multiply in this case by Avogadro's number, 6.02 times 10 to the 23rd particles per mole. And since we have 0.77 moles, we end up with 4.6
3 times 10 to the 23rd. Right? If we wanted to write this out, it would basically, it would be 0.77 moles, right, over 1 times 6.02 times 10 to the 23rd. I'm just going to repeat that, particles over a mole. And then cancel, and my units on the top are particles. So that's the conversion. Okay, so let's see, the next part of what we're trying to do is, now I'm giving you the number of particles, all right, and then I want you to find the mass. So here's the question is, okay, for this particular question is, how many grams are in 7.2 times 10 to the 25th particles of potassium chloride? All right, so here's my given. I'm given the number of particles, 7.2 times 10 to the 25th. Remember, when we go back into moles, again, we always are going to divide. So we need to divide by the conversion factor. In this case, again, it's Avogadro's number. From particles to moles, we use Avogadro's number because it's 6.02 times 10 to the 23rd particles per mole. And I get 120 moles. Now, you might look at that and say, well, that's a lot of moles. Are we sure we did the calculation correct? Well, don't forget here, this is 10 to the 23rd. This is 10 to the 25th. So that right there is a factor of 100. Right? So we've already gone 100 moles. That's 100 moles right there. And 6.2 into 7 is a little bit over 1. So this 120 actually does make sense when you look at it that way. 10 to the 23rd is 100 times less than 10 to the 25th. Remember, every time you go up 10, every time you go up a number here, it's one more 10. So 10 times 10 is 2, and that's the difference between the two. So we have 120 moles. Right, and now we're going back out of moles, so we always multiply. Here's my molar mass of potassium chloride, right? So it's going to be 120 times 74.55, and our final answer is 8,950 grams. So 8,950 grams. That's how many grams are in 7.2 times 10 to the 25th particles, right? So we've gone from both ends. We've gone from mass to moles to particles, and now we've gone from particles to moles to mass. So you should be able to do any of these types of calculations now based on the information that's provided in this tutorial. So if you still are confused, keep working at it. And if you're still confused after that, come find me and we can set up a time to further go over this.